So example number 1. We've got the log base 16 of negative 5x minus 6 equals the log base 16 of negative 4x plus 2. So a couple things I want you to notice here. Number 1 is it's just a single positive log on both sides. Okay, so this is 2 things I want you to notice on both sides. It's one of the most difficult parts is figuring out what method to use and when to use it. So number 1, single positive logarithm on both sides, and they have identical bases. Notice they're both base 16. So these are the 2 things that have to happen in order to do what I'm about to do, okay? So when you have these 2 criteria that are met, you can actually just take the argument of the logarithms and set them equal. At this point, under these conditions, we can just ignore the logarithm altogether. It just becomes simple algebra at this point. So, I'll move all of the x's to one side. I'll have negative x plus 6, that'll be equals 8. Divide by negative 1 on both sides, and I'll have x equals negative 8. Okay. And so there's one more step that you have to take when you're working with logarithmic equations. This is my potential solution. And I say potential because this could turn into a no solution. So what you do to check this is you need to go plug negative 8 in here. And you need to go plug negative 8 in here. And if any time you do that, you get a negative number, then it's a no solution. You cannot have a negative inside the argument of the logarithm. So let's check it. This will be negative 5 times negative 8 minus 6. Okay, so is that a positive or a negative number that we get there? I don't know. This will be 40 minus 6, right? Negative times a negative, and then subtracting, you'll end up with 34, right? Mm-hmm. So this is positive. Positive number there. And so that's good. Let's check it over here. This will be negative 4 times negative 8 plus 2. That's also 34, which is just a coincidence. What we're looking for is that you get a positive number in both arguments. So that one's also good. So because none of them give me a negative number, and I'm going to illustrate this for you in a second, we keep this solution. It is a solution of this equation. If it had given a negative number up here, we would say no solution and we wouldn't include it. So must give positive arguments. What's the argument? What am I talking about when I say that?
They equal each other?
It's what's inside the log. This in blue is the argument of the logarithm. You're going to hear me say that a lot, okay? But that's what I'm talking about. Like for this log, negative 5x minus 6 is the argument. It's what's inside of the logarithm. To be a solution. To be a solution. Okay. Let's do another one. Example again. Let me move up here. Example number 2. So this will be log base 15 of 3x equals log base 15 of negative 5x minus 7. Okay, so those first 2 conditions are met. I have a single positive log on both sides of the equation, and they have the same base. So I can just go ahead and disregard the logarithms, set the arguments equal to each other, and solve for x. Well, this will be 8x equals negative 7. So I just added 5x to both sides, right? We want all the x's on the same side of the equation. divide both sides by 8, and you end up with negative 7 over 8. And this is our potential solution, but we got to go check and make sure it's good. So let's go back up. We'll have 3 times negative 7 over 8. That's actually negative 21 over 8. So that's negative. This is a negative number in the argument. So what that means is that this is not a solution. So instead, your answer should be that there is no solution. So that's why it's important to check. You do not need the actual number here. If you can determine whether it's positive or negative without finishing it up, like me, that's a positive number times a negative number, I automatically know it's going to be negative. Beyond that, I don't care, right? So once I figure that out, if you would like to stop and just move on with your life at that point, then again, it's irrelevant what the number is. All we care about is the sign of the number. Okay. Let's do another one. Questions so far? Yeah? Okay. Maybe we'll have some later. Or maybe you'll ask me when we start working. That's fine also. Another example. Remember, the ln just means the natural log, and that's just a log base e, right? All of the stuff happens the same way. So this is the ln, the natural log of k squared plus 12, equals the natural log of negative 11k plus 2. Well, I have a single positive logarithm on both sides of the equation, and the bases are the same, right? The base here is e, so I know that it's cool. So I'm just going to go ahead and disregard those and write just the arguments. Well, at this point, it's just algebra again. And just to bring you back, this is a quadratic. You can tell because of the squared variables. So we need to put this in standard form so we can factor it. So this will be k squared plus 11k. I just moved this over here. Then I'm going to subtract 2 from both sides, and I'll have plus 10. Remember, the standard form is descending exponent order with a 0 on the right-hand side. So that's where we have to go first, because I have to factor this. How many solutions do I expect to see here?
2, right?
2, right? Fundamental theorem of algebra says that it's k squared, so I'm looking for 2 solutions. All right, so to factor this, I'm looking for 2 numbers that multiply to positive 10 and add to positive 11. And so my lucky numbers are 1 and 10, both positive. 1 times 10 is 10, 1 plus 10 is 11, so we got a winner. This will be k plus 1 times k plus 10 equals 0. And so if you remember, we set each factor equal to 0 and solve. And so here I'll have k equals negative 1 and k equals negative 10. So both of these are potential solutions, and we have to check both of them. But we will check them one at a time because they are separate from each other, right?
Hold up, can you rewind and do that last part again?
Sure. From here,
Yeah.
can you get the 1 and the 10? Are we good there?
No.
Okay, so this is a quadratic.
Mhm.
In order to factor it, we have to find 2 numbers that multiply to this number and add to this number.
Is all it can be set up like that?
Yes. Unless there's a number out here and then it's slightly different. All right, so then those 2 numbers are 1 and 10. So one factor is k plus 1, and the other factor is k plus 10. Just taking these 2 numbers and placing them here. Then we set each factor equal to 0. So really the intermediate step here is k plus 1 equals 0. K equals negative 1, and the intermediate step here is k plus 10 equals 0. And then you'll get k equals negative 10. Better? Okay. All right, so let's check these. So the first one I'm going to check is -1. So this would be -1 squared plus 12. Is that positive?
Yes.
Yes. So this is positive. So we're good there. Let's check it over here. -11 times -1 plus 2. Is that positive?
Yes.
Yes. Negative times negative plus a positive number is going to be good. So this is a solution. We're going to keep this one. The check marks are not part of my answer. It's just me saying, yeah, that one's good. Let's leave it. Okay, now let's check the -10. We got to check both of these because, again, they're distinct solutions. This is -10 squared plus 12. Is that positive?
Mm-hmm.
Yep, any number squared is positive, so that's good. Right. We still got to check it over here. -11 times -10 plus 2. Also positive. So that one's good. So how many solutions do we actually end up with? 2. So we keep both of them.
What happens if you didn't keep both of them?
You can eliminate one and keep the other.
And that'd just be an answer.
We're going to do one like that next. You got 3 options. You're either going to eliminate both of them and have no solution whatsoever. You could eliminate one and have one single solution in this case, or you could keep them both like we did here.
Real quick, off-topic question. What would we title these notes? Like for
Logarithmic equations. Okay. So this is example. Again, let's go again. Like I said, lots of examples. So this is log base 17. A squared minus 15 equals log base 17 of -6a plus 1. So again, I've got 2 single logarithms. They're both positive. That's all I've got on both sides. Both have the same base. So let's go ahead and pull this out of here. Equals -6a plus 1. This is a quadratic, so I know I need to put it in that standard form and get ready to factor it. This will be a squared plus 6a. Bringing this guy over will make him negative, so this will be -16 equals 0. So again, what I did here is just I subtracted the 1 from both sides. And I just added the 6a to both sides. Algebra. So again, here comes the factoring step. I need 2 numbers that multiply to give me -16 and add to give me +6. So
-2.
there you go. Be 2 and 8. You got to put the negative somewhere, and it's going to be on the smaller number because 8 plus -2 will give me 6. So that's going to give me my factors. I can go straight over here. A minus 2, a plus 8 equals 0. So again, that from here we'll set each factor equal to 0, and our 2 potential solutions will be a equals 2 and a equals -8. So now we just have some checking to do. So let's go do that. We'll check +2 first. That'd be 2 squared minus 15. 4 minus 15 is going to give me a negative number, right? So that's no. So this one is out. I don't even need to check this one. As soon as it gives you one that's negative inside of the argument, you can just disregard it immediately. All right, let's go check the -8. So this would be -8 squared minus 15. Well, that's 64 minus 15. That one's good. This one's positive, so we'll keep it. But we got to be good over here too. That's -6 times -8 plus 1. -6 times -8 gives me a positive number plus 1, also a positive number. So this one's good. So notice I was able to eliminate one of them, but the other one stayed. It's a pain to go back and check like that, but it's just part of the problem. Because if you give me both solutions, it's wrong. If you give me a number when it's a no solution, it's wrong. Okay. very careful. If you want to convince yourself that the negative in the argument's not cool, just pick any negative number and try to take the log of it. It's just not going to work. Okay, so,
Put it in the calculator when you're basing calculator.
yeah, it'll give you a domain error. So, okay, let's do another one. At what point does the whole game change here? I don't remember. Let's see. Oh, this one. So we got a completely different procedure coming up now. And you'll see that as soon as I write it up here, those criteria that we've been looking for in the previous problems don't exist here. Remember, in order to use that nice trick where I can just set the arguments equal to each other, I got to have a single logarithm on both sides, and we already don't have one on the right-hand side, right? It's not cool. You can't just say x equals 4. But let me kind of take an aside here and remind you of something we learned last week. This has nothing to do with this problem other than to illustrate a concept we're about to use. So this would be, let's say I got the log base 2 of 2 to the 4th. What's that? 4. And let's say I've got 3 to the log base 3 of 5. What is that? 5. Yep. So remember this trick. We'll go. So what we're going to do here is I'm going to notice that the logarithm is isolated. And it's base 5. So this is what I'm going to do. I'm going to say, okay, 5 to the log base 5 of x. Whoop, hold up. I don't want it right there. Equals 5 to the 4th. So notice, and this is perfectly valid. I can do that. I just raised both sides of the equation up as an exponent of 5. And I strategically chose the base 5 because it's going to eliminate that logarithm, okay, by this property. So what we're going to be left with is just simply x equals 5 to the 4th, which you can easily evaluate in your calculator to be 625. And that's our potential solution. If you go back up here, you'll see that, 625 just goes in for x. It's positive, so we're good to go. This is a solution. But this trick is what we use here. We strategically choose the base and bring both sides up as an exponent of that base. We're doing it on. How did I know to use this method? Well, I just had one logarithm, positive single logarithm with the number on the other side. Let's do that one. Log of x plus 8 equals 4. Again, we have the same set of conditions. We do not have a logarithm on both sides here. What's the base of this logarithm? N. It's common log. So in your mind, you should immediately be like, dude. And so what is the base I will choose in the next step? 10. So this will be 10. The log base 10 of x plus 8 equals 10 to the 4th power. This just conveniently just goes right on away. And we're left with x plus 8 equals 10 to the 4th power, which is 10,000. At this point, it was just algebra. We'll subtract 8 from both sides to get x by itself, and you'll have 9,992. Let's go plug it back in and make sure that our potential solution works. 9,992 plus 8 is a positive number. So we feel good about saying that is a valid solution for us. Oh. Classes start at CSU today.
Your classes?
No, not that I teach, that I take. The job and school.
My mom's doing that right now. She's going back to nursing school.
Yeah, nice. See, I one class. I tried doing like way too many and I almost killed myself. I almost didn't I almost ran myself into the ground. It was very bad, and I swore that no matter how long it took, my master's would just be one class at a time, except in the summer. All right, let's go again. This one's going to be slightly different. Okay, this one's something slightly different. So we're just going to keep going with a few different things, kind of adding conditions on in these different circumstances. All right, I don't have a logarithm on both sides. And I don't have a positive logarithm on that left-hand side. I don't want anything but the log. And there's a -1 out front. So by the miraculous laws of high school algebra, I'm going to divide both sides by -1. And I'll have log base 11 of p plus 1 equals +1. Right? Just write plain old algebra. Now I have a log that's by itself on the one side. Nothing else messing with it. No negative, no coefficient, nothing like that. And now I can go back to my normal trick. So 11 to the log base 11 of p plus 1 equals 11 to the first power. Just eliminate that completely. So p plus 1 is equal to 11 to the first, which is just 11. Yep. And so we'll just subtract 1 from both sides now. I thought we were good, computer. Let's see. All right. Am I done? Gotta check it, exactly. So let's go do that. So this would be 10 plus 1. That's positive. So I'm good. Do I care about the negative out front? No, I do not. All I'm checking is inside the parentheses, period. That negative out front does not concern me at this point.
On a quiz or homework check, will we get points taken off if we don't show if it's positive or not?
The only way that that's going to mess you up is if you don't check and it's a no solution and you give me a number. I don't need to see the work. I'm just showing you the work so you can see what I'm doing. But no, I don't need to see that. Right. But like I said, if it's no solution and you give me a number, then it's going to be wrong. Just be aware. So if you can check that without writing anything down, I mean, that's fine. Okay. Good question. All right, let's go again. Okay. Step that same idea up a little bit. This will be -4 log base 5 of 6p plus 1 minus 8 equals -4. So remember what I said. The goal is to get the log by itself. And the logarithm is this guy right here. It is log base something right here. I want him alone. And I mean, we're just going to use normal algebra. So think in your mind, when you're at this step, think in your mind how you would solve -4x minus 8 equals -4. And these are the steps you will take. What's the first thing I would do in this case?
Divide by -4.
Can't divide by -4 yet. I'm glad you said that. We need to add 8, right? Yeah. I'm glad you said divide by -4 because we always want to jump straight to that. First block did too. That's why I've chose this example. So remember, we have to add before we can multiply and divide. It's almost like PEMDAS in reverse, right? So let's do that first. I'm going to have -4 log base 5 of 6p plus 1. Add 8 to both sides, and this is going to be +4. Okay. Now we can divide that 4. Okay. Because there's no addition or subtraction to be done, so I'll have log base 5 of 6p plus 1 equals, just divide by -4, and divide by -4, and I'll have -1. So that looks much better. And I know that I'm ready now to use that trick that I use when it's just a log and a number, because I've gotten everything away from the logarithm. It's by itself now. So now I'm going to raise everything up as a power of 5. And we're back again where we were just a bit ago. Remember, this is that just kind of goes away there. That's why it's important to remember what you're trying to do instead of just trying to memorize steps, because there are a lot of different ways you can go here. That's why I say you need the log by itself. 6p plus 1 equals 1 over 5. Why did that happen?
Because of negative.
Negative exponent drops it down to the bottom. Good job. I mean, and now we just proceed. We don't care that that's a fraction because we have calculators, right? So we're just going to subtract 1 from both sides. You're going to have 6p is equal to negative 4 over 5. And again, all I did here was subtract 1, subtract 1. And then we'll divide by 6. And it's going to be some nasty number. I don't remember what it is. Negative 4 over 5 divided by 6. Negative 2 over 15.
Yes.
Yeah, it's gross. All right. I think this is good. I don't know. We got to go look. I think this is good. We got to go all the way back to the beginning, and this is where I want to plug it in. I don't care about any of this out here, okay? So this would be 6 times negative 2 over 15 plus 1. Now I know these two, this is going to be negative. I just don't know how big it's going to be. So this might be one where you actually have to plug it in. It depends. Depends on you. I'm going to plug it in just to be certain. Plus 1. That is 1 over 5. That's positive, right?
That's positive.
Yeehaw, we're good to go. All right. And that's it. We'll keep that one. So basically, I mean, it's just two main ideas here, and the rest is understanding that those logs have to be by themselves. And you're either going to have a log and a log, or you're going to have a log and a number. And those are the only two things. The rest is just getting to one of those 2 points. All these are exactly the same. It's just doing different things and knowing what you're trying to do. You're trying to isolate the logarithms. Okay, you need 1. Let's do another one. New strategy. Basically the same strategy, new tool to get there, okay? This will just be a little more sophisticated than before. So this is log base 7 of x squared plus 8 plus log base 7 of 4 equals log base 7 of 33. Now, you may look at this initially and it may be daunting, but just remember where you're trying to go. You're trying to get 1 log on the left-hand side and 1 log on the right-hand side. Well, a log added to another log on the left. And so, but lucky us, we know the product property, right? We know that we can condense that into a single logarithm. So recall the product property, when you see 2 logs added together with the same base, we can actually multiply those 2 things together and combine the logarithms. So this would be 4 times x squared plus 8 equals the log base 7 of 33. Well, see, now I just have 1 log on the left and 1 log on the right, which is what I need to use one of my strategies, right? Absolutely. So let's go ahead and simplify that argument on the left. So this will actually be 4x squared plus 32. Right? I just distribute the 4. You can skip this step if you want, or do it straight from the jump, whatever. Okay, so now I have that first thing I taught you where you have a single log on the left, a single log on the right, and equivalent bases. So now we can just disregard the logarithms. And at this point, I'm just going to solve for x squared and then take the square root. So I'll subtract 32 from both sides. 33 minus 32 will give me 1. I'll divide by 4. x squared equals 1/4. I'm going to take the square root of both sides, and I'm going to have x is equal to plus or minus 1/2. What I did here is I took the square root of both sides. Remember, the square root of both sides like that gives you a positive and negative answer. You have to deal with both of them. So we'll need to check positive 1/2, and then we'll go back and check negative 1/2, because there are two solutions there, even though they're written like this. All right, so let's do it. Well, these don't have any x's, so they're clearly going to stay positive, right? 4 is just 4, and 33 is just 33. So we'll check this first one. 1/2 squared plus 8, is that positive?
Mhm.
Yep. And then we'll do negative 1/2 squared. Let's see. Negative 1/2 squared plus 8, is that positive? Yeah, any number squared becomes positive, and then if we add an 8 to something positive, it's still going to be positive. So do we keep both of them? Yes. Yes, we do. So both of these are our solution. So again, let me walk you back through this one. So I have all this junk up here. I have all these things added together. Let me show you what you can't do. No. You cannot say, well, I have all three bases the same, so I'm just going to take everything and disregard the logs right now. That cannot happen. Okay? You are not going to get the same answer. This will be x squared plus 12 equals 33. X squared equals, I don't know what that is. Was that 24? I don't know. Anyway, something that's not this, right? No. The only time you can use the trick where you disregard the logs is when you have one log on both sides. One. That's why we learned to condense them. So we could use this trick right here. So this is no. No. Like broken-hearted no. Cannot do that. All right, let's do, I want to do one more for you, and everybody hates this one. I encourage you to watch me do it and then go back and write it down, because there's a lot going on, and I'm going to move quickly, and then the second time through, I'm going to slow down and walk you through it, okay? So this would be, ln of x minus ln. What's the base of the natural log? E. Good. You'll need that in a second. All right, so the first thing I see here is that there are two logarithms subtracted, and so I'll need to use my quotient rule to combine those. This will be ln of x divided by x minus 6 equals 2. Now that I have one logarithm and a number, I know what trick to use, and that's going to be to strategically choose a base that will allow me to eliminate the logarithm. In this case, the base is e, because the base of the natural log is e. This goes away. You're left with x over x minus 6 equals e squared. I told you I'm going to move really fast the first time, then I'm going to go back and slow down, okay? All right, whenever I have a fraction, at this point, it's just algebra, folks, and you're not going to like it, and that's fine. I have a fraction, and I would like to eliminate the denominator by multiplying both sides by that denominator. So that'll cancel, and I'm left with x equals e squared times x minus 6. I can't get this x over here with the other one like I want, because it's in parentheses jail. And so I have to break it out by distributing the e squared. At that point, these are added or subtracted, so I'm going to subtract e squared x from both sides. I can't divide it because it's locked up by this subtraction symbol. And now I'm going to factor out an x because I'm trying to isolate x. I need it by itself. And at this point, I'm going to be able to divide by 1 minus e squared to finish the problem and have x by itself. And that's it. All right. Okay. Now I still have to go back and check, but I'm going to leave that until just a minute from now because this is like super a lot. Okay. And part of the difficulty, and usually what tears you up here, is that you're like, the E is weird. It's a number like pi, but it acts like a variable, but it messes with your eyes and it messes with what you know you can and cannot do. And so it presents a problem for us. But the first step is that I recognize that I have this same issue where I've got two logarithms over here and I just need one. So I need to combine those. It is subtraction, so I'm going to use the quotient rule to combine those as a single logarithm. So I can use one of my two fancy tricks, right? So I will divide the first by the second. At this point, I have a single logarithm, that's good, check, and a number. And so I know my strategy for that situation is to take the base and raise everything up into the power of that base. I know the base of the natural logarithm is e. So I choose my base to be the number e. Everything else comes up top. These two cancel each other out because they have the same base. This is e to the log base e of this. That goes away, and I'm left with just this piece equals e squared. We do not like variables in the denominator of a fraction because they have to be dealt with for us to solve. And so I don't want this to be in the bottom anymore. And to get that out of the bottom, I'll multiply by it, and it will cancel. The golden rule of algebra says I also have to do that over here in order to maintain equality, right? So I do it over there. That's what I did. Let me scroll down a little and continue. So at this point, I've just multiplied both sides of the denominator of the fraction to get rid of it. Now, at this point, what you're going to want to do is you're going to hopefully think back to your algebra skills and you're going to be like, well, if I want to solve for x, they all got to be together. I cannot move this around while it's locked up in here. The only thing I can do is divide, and then I'm back here, which is silly. So I'm going to distribute to get them out of jail. Right? I'm going to unlock him. But then we get this nasty thing right here, which is fine because this is really just a number, like a 2 or a 6. Okay, so it behaves in the same way. Now you also are going to want to divide at this point. You cannot because it is chained to this. The operation here is subtraction or addition. It's a sum or difference. It's not multiplied by this. So in order to get this away, I have to subtract it because it's positive. I can't divide it. And so I just move it over here, so it's subtracted. Then I'm like, okay, well the x's are at least on the same side. But I really like it if I just had x by itself. And the trick to remember here is to factor the x out. Then you can get rid of everything else by just dividing by everything but x, which is what I did here. I divided this away, so I do it on both sides, it cancels, and then I do it here. And I'm left with this. Now, this is a number. I encourage you to plug it in your calculator and get a decimal for it, right? This is the answer. When you round it, it's some like non-repeating decimal, so it's not very accurate. So this will be your answer, but you can kind of get a feel for what you're looking at. Give it.
I'm confused about this, the step from x equals e squared x minus 6e squared to the next step.
Okay.
I'm confused how you.
I subtracted this from both sides. Because I want this x over here with this one.
Okay.
Better?
Mhm.
Okay, good. I want him over here, so that's the only way I can move him.
Yeah, I'm fine until you got to the x parentheses 1 minus e squared.
Okay.
I don't
From
think
here to
I-
here, you're not
no,
understanding.
No, from before that.
This?
Yeah.
Oh, so I just factored the x out. There's an x in both terms. And if I remove the x, I'm just left with the 1.
Oh,
Okay? And so then I've just got this business. And questions from here to here.
Where'd you get the 1?
When I factored the x out of the first term, it doesn't just disappear. There's a 1 there. So when I pulled that x out, it left a 1.
Okay.
Okay? This is really kind of pushing your algebra skills to the limit. like, this is a difficult problem for us now. By the end of the course, you'll be like, shh. Okay. But right now, you're like, Jesus. It's gonna be fine. We're gonna do some, and the way I encourage you to attack a problem like this, there's one on your homework, is what you're gonna do, you're gonna start it, and you're gonna get stuck. And then I or someone around you will help you get unstuck. And then we're gonna do another one, and you'll get a little further this time, because these work the same way every time. It's the same steps. Yeah,
Do we have to go back and plug this into the?
we do.
Oh my gosh.
Okay, so this is a number, right? So you can either go plug this whole thing in. What I do is I get a decimal approximation, I go plug that in, because it's easy. Okay, so I encourage you at this point to put this in your calculator. The E button, the E to the X button, is above the LN button. So you'll hit second LN, and it's gonna give you E to the whatever power. So, I hit my fraction button, and then go from there. So like, nice. See, those are some crazy doing number. Instead of typing that in and plugging it in, we can just type that, and it'll tell us the positive versus negative, right? Because that's all we really care about. You should get like 6 point something, something, something when you plug it in. Let me plug it in with you real quick. So I just hit the fraction button, -6. Yeah, this E squared. Everybody finding that E button? Okay, good. Yeah, like 6.939 or something. And I just like the decimal because even though that's my answer, when I go check it, I just, decimals are just easier to work with. So this is 6.939, and I can just take this joker up here and plug it in. So let's plug it in the first one. X is 6.939. Is that one positive? 2 seconds. Is this number positive?
Yeah.
Yeah. So we're good there. What about this one?
Yep.
6.936 minus 6. Yep, that's not very positive, but a little bit. So we're good to go. We're able to keep that guy, okay? But see, would you rather have plugged in the decimal or that fraction a bunch of times? Yeah, I'm not trying to plug that fraction in a bunch. That's a pain. Could you though? Could you, and it would work?
Yes.
Yes, absolutely. If you like pain.
Thank you.
You're welcome.
All right. Those are all my examples for you. I'm going to post your assignment on Classroom. It's odds only plus number 12. But that's listed in the instructions. So give me 1 second and I'm going to get that for you.